So, yeah, again, I'm Antoine. I've been at Ingen for about 2 years, and worked on the Java driver and the MapReduce engine within Mongo, and the JavaScript engine too within Mongo. So I know there's a lot of blame on MapReduce and the JavaScript engine, so that would be me. Well, the good news, well, I will talk about that later, but we have some good news on that front. So today I'm going to talk about Mongo 2.2. It's been delayed over and over for a long time, unfortunately. The reason is that, as we'll talk about, I came to an open heart surgery for MongoDB in terms of the locking system. So the locking system took just itself probably 6 months. So just that, a lot of other features were basically pushed back when most of the team was focused on making sure the locking system was right. In the future, we really hope that we don't have to re-architect anything within the software, so that some of the better features that take far less time will just make it to 2.4. So 2.4 should be pretty impressive. 2.2 is less impressive when you look at it, but really it was a required step, I would say. So just looking back at the history of Mongo, in 1.8 March 2011, we added journaling, which was really important for MongoDB as a database. So a lot of businesses would not even look at Mongo without the journaling. With journaling, you get two things. You get corruption prevention. So that's the journal is the only way for when you say pull the plug on the server or whatever, you bring the server back up, you know there's no corruption. Before the journal, or if you turn up the journal today, you have no idea if your data is correct or not. So journaling is there. The second thing it brings is durability. So you know in ACID, the D in ACID is durability, which means that when your client makes a write to the database, you can get an acknowledgement saying your data is on disk. And that's not the default. It actually requires an option that's called J in the write concern. So the reason why it's not the default is that it actually takes resources. I mean, it slows down the database to make sure that you do a write and you wait that it's on disk to get back to the application. So just so you know, if you're doing like financial transactions, very important data gets written. If you want durability, use the J option, potentially with a combination of replication too, to make sure it's also replicated. So that's enough on journaling. One more point. The previous talk was awesome. There was just one thing, like absolutely nothing to contradict with them. The one thing, it can be dangerous to run the journal on a different drive than the rest of the data. The reason is if you run the journal on the ephemeral drives of the server, and then let's say Amazon goes down, and if you lose the ephemeral drives that contain the journal, that's the problem, because then the data, you have no idea if your data is correct or not, and the journal is gone. So the journal is as important as the rest of the data, and typically you want to make sure that you can keep both. Like if one of the two is missing, if one of the two is missing, you cannot recover the data. So that's just one point. So some sharding, replica enhancement, spherical geo search was added. 2.0 was released in September 11, so we had a nice 6-month schedule. In index enhancement, we added the covered indices, sparse indices. That's very important for Mongo. The sparse index is so that if you have entries that are not in every document, let's say the Facebook ID, you only have 10% of your documents with a Facebook ID, and you're not actually storing it in a document, then you don't want your index to have an entry for every single document. You want only documents that have that ID to be in the index. You would use the sparse option. Covered index is really important for performance. If you do a query and all the data is within the index, you won't even touch the document on disk, I mean the actual document. That can speed up 10x the queries. Authentication in clusters, concurrency improvements. So the concurrency improvements started with 2.0. That was a huge step in terms of the write lock issue. That's probably the write lock issue is probably the #1 issue that's blamed on Mongo. And actually the next slide is on that, so we'll get to that. So now 2.2. The big feature is the aggregation framework. We've understood that people wanted aggregation. That was one of the missing feature, not just on Mongo, but of every single NoSQL database in general. So we wanted to, and the current MapReduce is too slow, is single-threaded, and it's kind of a pain to write. When you put JavaScript, it's fairly easy, but people were used to just a group bind with SQL. So the goal was to give such a feature. Multi-data center deployments, I think they mean sharding, geo-sharding. So that's a misnomer. And then improve performance and concurrency, that's also, most of the time was spent on that really. And so now, so yeah, it took almost a year, actually a full year to get 2.2 out. We're gonna stick to 6 months from now on. So that was pretty painful. So again, the features: concurrency, aggregation, tag-aware, sharding, geo-sharding, as we'll see, is a total misnomer. The read preferences, TTL collections is really nice, and some shell enhancements. So concurrency and database level locking. So there are two parts of the locking that are important. The first part is what the database does once it gets the lock. If you tested Mongo on a laptop, you are probably able to insert, say, like 10,000, 50,000 inserts per second. So the reason why it's so fast is because you're actually writing to RAM. And then the OS takes care of flushing the RAM to the disk. If you're writing to pages that are sequential, it's actually very few pages that need to be flushed to disk. So the flushing to disk is really fast. And then when the database takes the write lock for you to write, it does everything in RAM. So you can see that the lock itself is not a problem. Because as long as everything's in RAM, with the laptop you can do 50,000 writes per second. With a big server you can do like 100,000. The lock itself is quick. So it's not really so one problem is what you do with the lock. And the problem before in Mongo 1.8 is that the database could do anything with the write lock, including waiting on disk. So now let's say instead of writing sequential documents, you decide to write, you have fragmentation, so the documents get written to any spot on the disk. Before writing to a spot on the disk, the OS needs to bring in the page into RAM to write there. So Mongo would take the write lock, then try to write the data to RAM. You would get a page fault, and the OS would have to then use the disk to find the data, bring it to RAM, and so on. So you would end up with situations where the database takes the write lock and then does a seek operation, which can take 10 milliseconds. It's a matter of milliseconds. So now you're doing some certain queries take a full millisecond or more to be done. So that's when everything drops. The performance and since all the reads are locked during that time because the write lock is exclusive, then you get the whole performance dropping quite a bit. So that was the problem with 1.8. With 2.0, we introduced the concept of yielding. So what yielding does is that when Mongo realizes that it's going to page fault, meaning that it's doing a write, you got the write lock, it's doing a write, but the data is not in RAM, it will give the lock back. So if you consider this, most of the problem is gone. And actually, if you look at benchmarks, with 2.0, the read performance stays pretty much constant, even if the write clock is increasing and the writing is increasing. Now, there were limitations. First off, the yielding was not perfect. It was really simple. It was only on the primary key and not on every index. And if you were going to do a fairly complex write that would update many different indices, that would not yield properly. So that was one limitation. And the second limitation is that, well, still, if you're writing so much that the entire, Mongo will always give priority to the writes. So if you're just like pounding the database with writes, say many thousands a second, Mongo is still going to disregard the reads and just do the writes. And then you will end up with a fairly high write clock, and the reads are going to queue. So those were the two issues. To compound with that, now let's say you're in a situation where you do a huge amount of writing. Typically, you have like a big set of data that you want to do a batch load of all that. So your client is going to just write as quick as it can to the database. You're going to do like thousands of writes per second. Mongo gives priority to the writes. The reads are just stacking up. So that's a problem. The larger problem is that replication is stalled too, because replication is a reader. So while you're writing like crazy to the primary, your secondaries actually cannot keep up, cannot read. So you end up in situations where you're writing a lot, you lose replication. So bad situation. And that's why we've tried to, so far we told people to make sure you either have enough capacity or you throttle your writing. If you do a huge batch load, you want to throttle the writing, because Mongo is basically uses a greedy log for the writing. So now you understand the context. So with 2.2, we improved in two ways. First off, we made the yielding much better. So now the yielding is going to yield almost every time it needs to, and it's a totally generic framework, so it's going to apply to any sort of index, any sort of query, basically, on the update. The second important thing is that we increase the granularity of the lock. So instead of being global, it's per database. So a lot of people are like, oh, it's not enough, it's still a database, it's still way too, like not granular enough. But now you can understand that, first off, the situation where you get maximum write clock is when usually you do a batch operation of writes. So it's usually rare. And even then, with the database lock, now the replication, since it's the local database, the replication is done through the local database, so it gets its own lock. So you know that the replication will never get starved by the writing. So that's a huge win. Also, it's now that you have the liberty to, the freedom to create several databases, you can sort of decide which content could use its own lock. Let's say you have some core data, your customers, and you know they are not written to very often, but you want to always have access to it. And now you have another database where, another collection where you're just writing logs. And that one can go nuts sometimes, and you may write too much. You don't really care if you cannot read from it. You really want the access to the other data to be fun. Well, then use separate databases with 2.2. Use database for your core data, a database for your logs, and then you'll have also a log for the local database. Make sense? Any questions on logging? Yeah?
I might have missed this, but you mentioned that when it's about to go to page 4, then it yields the log, right? When does it get it back? When does it get it back so it can do the actual write?
So then it waits for the data to be loaded to RAM, that one thread, and then it just puts itself back in the queue. So we'll get it back.
It knows that when the data is go back there, or it just checks intermittently that, oh, is the data in the RAM yet? Not yet.
Yeah, it uses a system call to touch the data to make in RAM, and that one is blocking. So it doesn't have to keep checking. It just, once the data is, the system call returns, it knows it can put itself back in the queue.
So it stages it? So it stages the data to RAM, what you're saying?
Yeah, it touches basically the location on disk.
So stages, yeah.
Yeah.
It causes it to stage. Yeah.
Exactly.
Quick question.
Yeah.
You said for financial data, the J option?
Yeah, it's called J, which is, it should be called...
The letter J? Or
Yeah, the letter J. Yeah, we keep on finding stupid names. It should really be called JSync.
Okay.
JSync would be much clearer. But you wanted to go in the vein of the W option, the J option.
Oh.
So, yeah, the one note with the J option, it waits for the journal to be flushed. So those queries will have extra latency. So if you use the J option, you use more connections. You will need more connections. Okay, so now the aggregation framework, we aimed at replacing most of the common functions. So things like grouping and applying an average, sum, the basic math operations. So we have defined, so it's implemented in C++, much faster than using JavaScript, obviously. It's multi-threaded. Whatever thread you're running it with will do the aggregation. It's really a pipe operator, so you can pipe several operations. Examples are projects, which will take your data and sort of modify the input. So you can select certain fields and modify the nesting. There's unwind, which will, if you have a list, then you can unwind the list, sort of like explodes the list into several different inputs. Then you can group, sort, skip, add, and so on. The $add is sort of like string functions. Within each function, within each command, you have many functions. So typically, if you want to count the tags, like if you have blog posts with tags, and you want to count how many times a tag appears, you would unwind the tags. So then you end up with one entry per tag, and then you would group by tags, and then when you group, you do the sum. There is a dollar match to filter the input, and it will make transparent use of the index of whatever indices you have. So obviously, if you want to do a specific match or a specific sort, it's better if they are to the beginning of the pipeline, because then Mongo will recognize it and use an index. If you wait and bury it after a few projects, it won't be able to recognize the index. And of course, the difference between using an index and not using one can be enormous.
Can you clarify what you were saying about you're running the aggregation functions across multiple, you have access to multiple threads? Is that, if you're aggregating one set of data, are you able to use multiple, is it using multiple threads, or is it only using one thread at that point?
No, so it's only the thread bound to the connection, bound to your client's thread that did the query, that will do its own aggregation. So it doesn't go nuts and like spawns many threads and does everything in parallel. The idea is that each aggregation should be self-contained, and you may be running like thousands of them of aggregation at the same time. So actually that brings a good point, and related to the limitations of the aggregation framework. And it's definitely not perfect, not as perfect as we wanted to be in the first place. The main limitation is that the output has to fit within one document. So you have a limitation of 16 megs for the result of the aggregation. This is pretty limiting compared to MapReduce, where the output can be as large as the input. It can be sharded, and there is no problem there. So right now, we're going to add a new pipeline operation called $out in 2.4, and that will let you just aggregate anything and send things to the disk. But the idea right now is that the aggregation framework never uses the disk. Everything runs in RAM. So if you can think of operations that in your mind would not run well if they were all stuck in RAM, you don't want to use the aggregation framework. So the bottom line is that if you want to do aggregation where you plow through your entire input and you want to create, like, modify, group, and create a massive output, look at MapReduce. Use the Mongo MapReduce or use Hadoop. If instead you want to do very targeted aggregation, either through a batch job or somebody wants to, like, on the fly do an aggregation of something, then the App framework is awesome. Because it's going to be right on the database, C++, use the index, it can't be any faster. So that's the idea for now. Yep.
Is 2.4 considering a union function?
So between different...
So right now with the new aggregation framework, you can effect have sort of one vector, you can have one sequence. So like in SQL, for example, you could have a select and group by union with another select and group by union with another select and group by. From what I've seen in the aggregation framework, you can't really model that. There's no notion of a union operator between multiple aggregate sort of vector pipelines.
So that's not planned so far. That also goes back to the fact of being able to union indices, which Mongo does not support today. The reason is that doing unions is oftentimes, in some cases, can be fine and rather fast, but sometimes if you abuse it, it can be crazy. I mean, if you do everything in RAM, it may not fit there, or you have to use temporary storage. So, and you potentially need to use sorting in order to do the union right. So I think once we have intersection of indices, we can definitely leverage that to do union on the aggregation framework. But that's, I don't know if that's going to be 2.4. Was there another question? Or, no. Okay. Yeah, just to finish on MapReduce, the work was done in 2.2 to switch to V8. And unfortunately, we wanted to sort of freeze the development of 2.2 because we were already really late. So we didn't want to jeopardize the release of 2.2 by switching to V8, even though the code was pretty much ready and multi-threaded. So the good news is that with 2.4, we're actually looking to switch right away. So it may be done already, but basically switch the whole internal tangent building tools to use V8. If you really want to try at V8, you can today. You just have to build Mongo with the --use V8 option, and then we'll use it. And then we've seen, yeah, I don't know, like with the comparison between V8 and SpiderMonkey, it depends what you're doing. Certain loops are going to be 100 times faster. Some other code is going to be about the same. But at least it's going to be, at the very least, it's going to be multi-threaded, which is a huge win.
What is 2.4 decided to be released?
That would be 6 months from now. Okay. So now, tag-aware sharding. So that's the right name for it, tag-aware sharding. It has nothing to do with geo. The idea is that you can add a tag on your shards. And so, for example, you can tag them with a location. So you can say those shards are East Coast, or those shards are SSD fast drives. Those shards are archival. And then you can specify a range within your shard key and apply a tag to it. So here, specify a range by tag. So then, for that range, you want to tag A. So this is, I mean, the original goal was to support geo-aware sharding. What geo-aware sharding is, and that became more generically this tagging system, is that let's say you have a whole sharded cluster, you have 4 shards, and you have 2 shards in each two shard in the West data center, West Coast, and two shard in the East Coast, you want the writes to stay local. So most of your users east, you want the writes to happen to the east side, and same thing on the west side. So write locality is very important for a lot of businesses. Not even talking if you have databases in Asia or in Europe, then it's really important because the connectivity is really bad. So now let's say, well, for this example, let's say you have US and Asia. Now, by default, Mongo has no boundaries on the chunks. It just tries to keep each shard balanced. So if you have more users in the US than in Asia, Mongo is going to start moving your US customers to Asia. And then your writes actually go over the ocean. So what you want to do with tag-aware sharding is to say, for those chunks of my data, I want them to be stuck on those shards. In the past, it was possible by disabling the balancer and then doing it yourself. But now with this, you can tag those shards and you can tag your content. If you want, so it's not related to geo sharding in that you still need to define the shard key as being geo-related. So let's say if you wanted to have like your shards in the US and shards in Asia, your shard key would have to start with the geo codes. I mean, the location of your, so you could say, oh, my shards, my documents will have a geo code, which is 0 for the US and 1 for Asia. And that has to be the first part of your shard key, because it has to appear somewhere in your shard key. So it's totally generic. You can build like really interesting system with it. And again, you can do, say, also the live shards and the archival shards. That's possible too, and play with that. Yeah.
Right. So if, let's say you added some tags for the short, do the documents themselves, as you do new documents in your collection, do you have to use that tag, or does Mongo take care of that for you?
So whenever you insert a document, it has to contain the shard key. So you're forced to have the shard key specified in your document, so that Mongo knows to it. So if you insert a document, then you know that user belongs to the US, and so that it would be set that way. So moving along. The read preferences, that lets you basically have more control over which secondaries are used for the read operations. So in the past, depending on the driver, by default it only reads from the primary server, and then if you use slave OK, it would read from the secondary servers. But there were lots of inconsistencies between drivers. Some drivers would only read from the secondaries if you use slave OK. Some other drivers would read from any server. And then some drivers would be fancy and look at which one is the closest and so on. If you use Java, that was the case. So we wanted to basically be more precise and really standard across drivers on how to set that, because it's very important. So now you can tag, again, you can tag your replica sets, your shards, and then say, I want my reads to happen on secondaries that are in data center A. And so you can play with that. Also, you can pick if you want the primary only, or if you want any server, or the secondaries only. And you can also use nearest, which will give you actually measured latency to the servers. Okay? Now, TTR collections. So that one is interesting, and it's actually a very quick, that feature took probably 2 weeks to put in, as opposed to the year that took MongoDB to that too. The reason is that it doesn't do anything crazy, anything magical. It just has a thread that runs within Mongo that will look at a specific field and delete documents that are where the field is using a date that it's expired. So it's the equivalent of you running a cron job doing the same thing, but you don't have to maintain the cron job, you don't have to run it, you don't have to, it doesn't have to like fail and then you end up not cleaning up your data for a year and you don't realize it. Also, it will make sure it's using the proper index because you declare it on the index. You can see ensure index. So that will make sure it's fast. The one thing that cannot be used on cap collection, obviously, because you cannot delete documents on the cap collection. The one thing that's interesting that probably few people will know is that internally it will make the use of a new flag that's called power of 2. Use power of 2 sizes. Use power of 2 sizes. That flag, which you can use on any collection, will make sure that every document you create, the size of the slot on disk is a power of 2. That means that you will use more storage, but each slot would be extremely reusable, so the fragmentation would be very contained over time. So it totally makes sense for this collection to use it, because since it knows it's going to delete a lot, it will make sure the slots are totally reusable for the documents. Okay, there was a question?
Yeah.
Okay.
So you don't have to do your own compression on it. It handles that for you.
Right, so in the future, we'll be able to do further features that are interesting. I think since we know in advance how you want to delete the data, when we do like live online compaction, we'll probably make it part of the TTL collection. Today we don't compact because since we use power of 2 sizes, the fragmentation should be really contained.
So how often that background thread runs?
I'm not sure. I would say like every minute or so.
So that 3,600 is roughly, right? Roughly it will be deleted after 3,600 seconds.
Yeah, so that would be 1 hour. So I don't know if it's every second it runs or every minute. I'm not sure. But it's going to use the index no matter what. It's going to look at the index and be like, give me the latest values you have in there. And that's basically free in terms of processing. So if we run it every second, every millisecond, it would not make a huge difference to Mongo. Okay, any more questions on TTL? The shell enhancements, I actually worked on that stuff. The first part, it should actually be the default of the shell. Yeah?
Sorry, question. From the MongoWire spec, is there like, are these just new properties added to the queries through the wire, or other?
For which feature?
Just like the expiry and stuff like that.
Yeah, no. So the expiring, that's just when you create the index, and then
If I'm writing a driver, is there a lot of new stuff added to the spec that I have to add?
yeah, so that would be part of the options of each command. So it's not actually changes in the protocol.
Okay.
It's just changes in the options that are available. There is like use of power of 2 sizes for the collection. There is the expiry for the index. There are probably a whole bunch.
Okay.
So here the first option is called verbose. You would do set verbose true in the shell. That should actually be the default, but it probably will be the default in 2.4. What it gives you is that it will actually tell you what it's doing, what happened to the database. So if you do an update of a record, and you do multi, it will tell you, I updated 2 values. If you remove documents, it will tell you, I removed 10,000 documents. That's better to know than in the past where you actually have no idea how many documents were removed or updated. So set verbose true, that's your friend. Save OK, it's just that you can set it in the shell, that's not very interesting. Okay, more replication. So now you can set which other replica should sync from. Very little known feature of Mongo is that it can actually daisy chain replication. And that's been around since 2.0, but almost no one knows about it, and we don't really want to advertise it. But it's because it's sort of really static. It's just when you start up Mongo, it will pick the closest server, and then try to stick to it unless there's a big problem. But now we let you pick, because that of course backfired in some cases. Because then if you have a whole bunch of servers bound behind one server that cannot access the other server anymore, it seems like it's running, but it's not getting any more writes. So you have a whole bunch of replicas that are not keeping up. So you'll be able to pick which server you want to replicate from, and effectively daisy chain. So that's kind of a cool feature. The tools, there is Mongo uplog, which lets you reapply an uplog. That's great to do incremental backups. So if you do a backup once a day, why not also doing a dump of your uplog every hour? And then if you have to recover, you can recover up to the last hour. That's pretty neat. The uplog is going to be fairly small, and the nice thing about the uplog is that it's totally idempotent. So you can take the same uplog and reapply it 100 times, you will end up with the right data. Because an increment becomes a set, and so on, we make everything be idempotent. So Mongo uplog, authentication support is better. We close some loops in the authentication. There were some bugs in the authentication with sharding, in that it was not properly implementing, the exact bug is that it's not properly implementing read-only users, because you can still write through comments. So we had to rethink the entire authentication protocol within the cluster, and that's going to come up in the next slide. So that's going to work much better. The query optimizer, the second line is very important. And that may be the most important feature to most of the developers. But of course, it's tough to document it. And a lot of people assume it's working fine today, but it's not. So the exact feature is the $in plus sort plus limit. What is that? Let's say you have a site, social network, you have friends, you want to find all the messages, all the tweets by your friends, sorted by time, and you only want to see the last 100. That's the single most typical query you want to do for any social network. And God knows we got many social networks on Mongo. And they all use, or try to use this query, which is $in all my friends, dot sort by time, dot limit 100. And that works absolutely not well in Mongo so far. The reason is it does not take into account the limit during the processing. So it will go to every friend, take all the tweets they have so far in their lives, use, fortunately, the index to sort it, but then it will need to merge sort the entire set of each of your friends. Then it's going to take 100 from it. So from there, your query is going to be super fast the day you build your site, but after a year of running your super successful site, it's going to become horrible. With Mongo 2.2, it now takes care of the limit when it looks at each branch. So that's going to be much better. Yeah.
Is there any particular optimization for skip as part of this?
For skip, it's still going to iterate through the elements. So we tend to recommend not using skip at all, as much as you can. The reason is that it actually has to physically skip over the elements, and it tends to be much better to use an index. I mean, to look at the values and do a less than or greater than using an index. If that makes sense.
Yeah, sure.
So that's pretty important, and that's good news. Now, yeah, in the future we'll go even further. We'll make it like we'll make it do a merge sort as it passes through the different branches and so on. But that means like pretty much multi-threading at that point, and we're not there yet. MapReduce will now work with a sharded output. So if you do a massive MapReduce and you want to shard the output, there's now a lot of logic to create initial split points to make sure it's balanced and so on. Getting started, you know where to download Mongo, it's there. Result issue, backward breaking changes. So how to upgrade? It's really a standard incremental update. So you can really update it as a drop-in replacement, as if it was a minor version. There are some, so you can follow, like for replica site, you want to start with the secondary servers and do them one by one. For a sharded cluster, you would start with the MongoS, then the config servers, and then do a rolling update of each shard as a replica set. The two important things to note is the chunk balancing gets broken in a mixed environment. So if you have one shard into that 2 and the other one's into that 0, don't stay that way for long, because it won't be able to balance anymore. The second thing is authentication. Remember, we had to revamp the authentication within the sharded cluster. That actually breaks, makes it incompatible when you're in a mixed environment. So if you use authentication today with a sharded cluster, you're probably looking at downtime to upgrade everything. That's one issue we're looking into. I don't know if we'll be able to make it backward compatible. Because now you will also have to support whoever upgraded to that 2. So not sure the status of this, but that was reported after we released to that 2. Yeah, okay.
That was my book.
Oh,
I was
you
already reported that one.
Oh, okay, all right. Well, yeah, so I don't know exactly what's the status today, but yeah. Thanks for reporting that.
You're welcome.
And of course, check out the release notes. What's next with plus 2.2, so meaning 2.4, we want to integrate with external authentication systems, LDAP and so on. A lot of people want that, even though typically you should only have a few users for your database. And then it's better to handle user authentication as a separate like API within your API layer rather than Mongo. But we'll add it. The reduction fragmentation, not sure what that is. I think we're going to try to start doing online compaction. The one big feature is going to be full text search, and that's sort of like the unicorn, because it's been like asked for so long, and everyone wants to see it. And it's actually running right now. I mean, we're using it to implement the search with intention on some sites. So it's been coded for over a year. But we want to get it right, and most likely it's going to be the big feature in 2.4, as the Ag framework was in 2.2. The other improvements, we want to try to make the lock more granular, and the Ag framework will get better with the output to collections, and also sharding will get improved. And then further, it's going to be better optimization using the indices, including multiple index on a single query that goes back to basically the intersection of the indices. So it's there. That's it. We're still hiring, and that's not my email, but yeah, don't hesitate to contact us for any questions. All right, any more questions on 2.2, or are you ready to go home?
So going back to the locking, let's say you got Twitter and you have, tons of writes as tweets are going out. You're suggesting just keep that in a separate database and then have the user data information in a separate database, and that'd be recommended.
Definitely, if you have some collections that have a very high write throughput, it's a very good idea to give them their own database.
Even if there's only one collection in that database.
Even if it's a single collection. I mean, in the past, you might as well also have done different clusters. So you could have one cluster just for that, but that leads to just administrative overhead. And sometimes people would create, in the days of 1.8, people would actually create shards within the same server. So you would have 3 servers, but then have sub-shards within that, and actually be running like dozens of MongoDBs just to have several write locks. You don't need that anymore. There's no reason whatsoever to run more than one MongoDB on the box. And now you can basically make use of the several databases. All right, any other questions? No? Great. Well, thanks for your attention.
Before you go, we're going to do a demo of MapReduce, where basically everybody just, when you get up, grab your chair and put it over there. Thank you.
Good.